Welcome to the next phase of the Introduction to Data Science for the Built Environment edX course. As mentioned previously, we will be learning data science through each of the life cycle phases of the building industry. This set of videos will take an in-depth look at the design phase of buildings. Architects and engineers in this phase are planning the construction of a building using modern tools that create large amounts of data. Much of the data created in this phase is in the form of building information models. These models, also known as BIM models, are virtual representations of future buildings. The models themselves are generally used in three ways. First, they are used to create the construction documents that are used to specify and fabricate the building. This extraction often results in traditional two-dimensional floor plans. Next, BIM models are used to capture the characteristic metadata about the building components. For example, the model would store information about the materials of a wall assembly in addition to its dimensions and locations in the plan. Finally, the models are used as the digital twin input for simulation programs that predict how the building might perform in reality. The most common simulation types are focused on energy prediction. BIM is fueling a new paradigm called the integrated design process. The old way of planning buildings usually resulted in the handing off of design between disciplines. For example, once architects were finished with the schematic design, only then would engineers begin to work on systems like lighting or cooling. On the other hand, the integrated design process has changed things by getting all of the stakeholders to the table to make decisions as a team. For this team to make decisions in the integrated design process, they need to compare different combinations of proposed design features. The status quo design is often called the baseline. Proposed design options are created to be compared to the baseline to show the impact of different features, such as better facade or cooling systems. In terms of data science, the output files generated from the simulation of these design options are processed to quantify their performance impact. In this set of lectures, we will dive into the processing of simulation output files from the Energy Plus engine for a theoretical case study. In addition, there is a video posted that covers the aspects of the integrated design process for the SDE4 Net Zero Energy building here at NUS. This graphic illustrates the iterations of the proposed designs for this building that led to a strategy that creates as much energy as it consumes throughout the course of a year.